Well, good morning, everyone, and welcome. My name is Sean Conley, and I'm the State Soybean and Small Grain Specialist at the University of Wisconsin-Madison. Today, we'll be doing our Science for Success program, sponsored by the United Soybean Board. So I'd like to thank the United Soybean Board for sponsoring this project and this program. I'd like to welcome my panelists today. The panelists today come from across the United States. They will be Jeremy Ross from the University of Arkansas, Emerson Nofziger from the University of Illinois, David Halshauser from Virginia Tech, Manny Singh from Michigan State University, and Mark Licht from Iowa State University. We will also have two guests come in and give short presentations about, one would be Emma Maxim, who's a graduate student here at the University of Wisconsin-Madison. She'll be talking about some of the national work we've been doing on prophylactic micronutrient applications. And then also we will have Damon Smith come in at the end of the program and discuss some of the work that he's been doing with Sporecaster and Spore Buster, which is a prediction app for white mold. So with that, I'd like to again welcome everyone. And I'd like to give a special shout out to Sheila Hebenstreet. Hey Sheila, I haven't seen you in like 2 years, so it's good to see you on the program, or at least on today. And we'll get things started with a quick update across the country. So I think I'll start with Jeremy Ross. Jeremy, can you give us an update of what's going on in Arkansas?
Sure, Sean. It's kind of been a weird spring. I think we're almost finally done planting beans. We've had a number of acres had to be replanted. The first week of June, the week of June 7th, we had a system come through and dropped about 20 inches of rain in about a 36-hour period across about 11 states. So rough estimates, about 500,000 acres were impacted by that flooding event. Half of that was soybeans. Most of those had to be replanted. Once we got ready to start replanting, it got pretty hot and dry. And so we've gone from one extreme to the other, and but farmers are trudging through. I think most everything has been replanted or planted for the first time. Right now we're pretty dry, and so the beans that have been planted in the last 10 days have not had a shower, and a lot of them were kind of dusted in. So I've had numerous calls on the, do I think they're going to get a stand if the beans are still hard, or if they've swelled, had some moisture, swelled, and then just pretty much dried up. We got, as I mentioned, it's all over the board. We've got beans going into mid to late reproduction. And then we've got beans that were just been planted in the last 7 to 10 days. So we're all over the board this year. Acreage is up a little bit. We're at 3.1 million acres according to USDA. So that's in line with where we've been historically, except for the last 2 years. Just starting to see, our late season diseases and insects starting to show up because of some of the wet, dry conditions we've had, some nutritional deficiencies, but hopefully we can get some irrigation going and see, try to eliminate those problems. But overall, somewhat normal year, other than some of the weird things we've had going on. But hopefully we can finish out the rest of the year and have a good late summer.
Jeremy, and I'd just like to remind the audience that if you have any questions for the group, please put them in the chat. And when we get done with the state updates and kind of a sense of what's going on across the nation, we can just ask those questions to our panelists. Our next panelist is Dr. Emerson Nofziger from the University of Illinois. Emerson, you're up.
Good morning, everybody, and welcome back. A month ago, we were really singing the blues about when is it going to rain, and I guess we need to be careful what we wish for, because certainly parts of Illinois now are sort of soggy, and it's likely in the next few days they'll get more soggy. That's the biggest single problem we have right now. There is still some dryness up in the extreme north and extreme south in the state. but our rainfall was below normal up to the last week of June for June, and it ended up above normal by a couple of inches. So that was just too much rain coming in too short a time, and our crop that had been, looking like it needed rain now looks like it needs sunshine and drying conditions. And honestly, for some of it, that's not going to be enough. Our crop condition has deteriorated a little bit. We were at 22% blooming, flowering by 4th of July, and that's right on track with what our last 5 years have been. So that's a good thing. Where the crop really was growing slowly, and I get reminded and have to remind myself not to look too closely at soybeans during the month of June. If they're there and they're green, there's always potential, and that's certainly going to be the case this year. Some of our earlier planted soybeans now, where water hasn't stood, look really good. Where water has stood, I would probably be talking to crop insurance in some of those, because they're bright yellow. It's not sulfur, it's lack of oxygen, and they're not coming back. Corn probably is hurt more, but we can't see it as well because it's too tall. And it's a disappointment. In some parts of the state, are not experiencing this, and some parts of almost every field are not experiencing this. But it's a little bit of a rerun of 2015 in some places, where we had just way too much rain during vegetative growth. And, root systems are just beat up. And this is a point where soybean root systems have a chance to grow back still, but they need to get oxygen into the soil in order to do that. So we're at 63% good plus excellent, which is very mediocre. It was better than that a month ago. That's never a great sign, but we still have good potential in most fields where crop color is coming along. I think we'll be fine.
Emerson. Our next panelist comes to us from Virginia, David Halshauser from Virginia Tech University. David, the floor is yours.
Thank you, Sean. We're having a good year in Virginia. We started out very dry. April and May was two of the drier months I remember in a long time. Corn growth is not very good, but we started getting rain late May, June, and through July, just some timely rains, not a lot. I wouldn't rate the soil moisture as excellent, but it's adequate for right now. I was seeing drought stress in corn this week as I was driving around, but the tropical storm Elsa came in very timely for us. We probably got anywhere between 1 and 3 inches, depending on where we are in the state. And keep in mind, in our low water holding capacity soils that we have throughout, the southeast, either sands or clays, either one, the saying is we're 10 days from the last rain to the next drought. Well, it's not always that bad, but 2 to 3 weeks away, we'll be in drought situations again if we don't get the rain. So I'm pleased. Soybean growth is not great. It's not what I'd like to see, but it's adequate, I think, for right now. And these rains will definitely help. I think before tropical storm, we were rated about 60% good to excellent, very little into excellent. And I would agree with that throughout most of the state. But this is a real shot in the arm for us, this rain that we just had yesterday. It blew through really quick. Now the sun's shining today. We're almost all planted. I saw only one wheat field that hadn't been harvested, but our double crop acres is down to only about 20% of our acres. Historically, we've been 40, 50%. So wheat yields were not very good this year. They were probably average across the state. I think Maryland, Delaware, they're finishing up their double crop planting. And of course, Pennsylvania will follow that as well. So, in general, we're in good shape. The early maturing varieties, that would be group 3s and early 4s for us. They're starting to flower. But most of our state, we plant 4s and 5s, and that'll be later in July, or double crop won't flower until early August. So in general, we're doing very well. We need to continue to get these timely rains.
Thank you, David. And I had a message that I'm sounding a little tinny today, so I apologize. I think my computer is about ready to explode on me. So if it does, one of the other panels will have to take over for me. So anyway, thank you, David, again. And I'd like to go over to my next panelist, Dr. Manny Singh from Michigan State University. Manny, the floor is yours.
All right. Thanks, Sean. So I would say this year's crop was planted relatively early for us, following the trend we have seen over the last few years with early planted soybeans. And that did work out okay. The planting conditions were fair to good, but afterwards it turned dry. And I mean really dry, and it was cool to begin with. And Emerson was alluding to that as well. We had a slow start to the crop growth. The canopy development was not ideal, but that dryness early in the season was a big issue for us. It caused some spotty stands, I would say, as well as more variability in our stands too, which is again less of a concern in soybean compared to corn, where we have seen emergence basically 2 weeks apart in the same field, and that might have some consequences. Some frost occurred early in the season, especially in those early planted beans. So that caused some of those low stands as well. And we had some issues with the seed corn maggot early in the season, especially in fields that were in cover crop and planted soon after termination. So that was one of our issue, I would say. But again, with soybeans, they're more forgiving with that relatively thinner stand. So we'll see how that goes. Our crop was rated, I believe, around 60% in good to excellent, which seems about right. And some of the early planted beans were blooming early July here, I think around 10% or so, and some were even in early pod development phase. But about, I would say, around June 25th or so, we went from that too little to too much of moisture, and that Emerson was talking about as well, especially in southwestern part of the state. Those storms just kept coming, and I think we have had more than 6 or even 8 inches of rain in a lot of our parts of our state over the last 2 weeks or so. And that has caused concerns with waterlogging and submergence and potential impacts of that. So I believe that is our biggest issue. The dryness, I don't think soybeans really were that much impacted. There might be some yield impacts on corn because you're already determining some of the yield components, but soybeans, I think, were okay. But this relatively wet weather we are seeing, and there's more rain coming, I believe, next week. That is our biggest concern that I could think about. And I would say white mold is going to become a potential issue because of this moderate to high moisture conditions that we have. And you mentioned, Sean, I think David is gonna talk about that. So that'll be good. What growers can do to assess their risk, especially using that Sporecaster model. I think that's all I can think about. Oh, we had some issues with the potential weed escapes as well early in the season due to those dry soil conditions and herbicide activity being impacted because of that. So that's something that we are trying to keep an eye on. I think that's all I could think about. Oh, one last comment I would say is I have heard a lot of interest in double crop soybeans too, especially in southern Michigan, where there is we are a little bit north for double crop success, but growers in southern Michigan have had success there, and there's a lot of talk about that crop with these high soybean prices. Moisture is our main limiting factor on top of a relatively short growing season. And with plenty of moisture available, that is something our growers can keep in mind. That's all.
Thank you, Manny. And I think that's a topic that I'll revisit when we get done with all of our discussions across the state, and we'll talk about double crop management across the country. So our next panelist is Dr. Mark Licht from Iowa State University. Mark, the floor is yours.
Oh, good morning, everyone. Iowa is in a unique situation because it's the tale of the haves and have-nots. We have a good portion of the state, probably 2/3 of the state that's not had any rain. A large area for April, May, and June had anywhere from 10 to 50% of normal on rainfall, and the 50% has not been a consistent part of the state. So we have our northern crop reporting districts and our central crop reporting districts where we're in the top 10 driest years of the last 100 years. So it's been quite interesting there. And then we have the southeast part of the state that keeps getting rain. It started out a little bit dry, but then keeps getting the nice rains that come through out of Missouri. And so Southeast Iowa looks a lot like Illinois and Missouri right now. They did have a little bit of replanting because of too much moisture in that part of the state. So that's been quite interesting. And then with some of the storms of the last couple of weeks, we've been having some thunderstorms that have some isolated hail. One storm went through and they actually had rain hail on the roads the next morning, and they were using snowplows to push it off. So stripped soybean plants rather nicely in that area, but did not damage the axillary buds or the apical meristem in all cases. And so they're growing back fairly nicely right now. So we've been dealing with that and talking a lot about drought conditions and what to expect. The ag media definitely gives me a call about every time we get a rain and asks if the drought is over with. And if we don't get rain, then they're calling and saying, what is this doing to yield potential? And so, we can talk about yield potential and with our varied conditions, but as others have alluded, right now we're just too early to tell. We have the potential to put out some nice yields still if we can get some rains that come through here in the latter part of July and August. And so while I do think we've probably lost the top end of our yield potential, I think we have the potential to have some pretty good yields still. So I think maybe that's where I'll leave it right now, and then we can come back around for some questions as we have time.
Thanks, Mark. Yeah, our university went on high alert and started talking about drought and putting out all this drought information, and then it started to rain. So that's what we do here at UW-Madison. So anyway.
Well, today we're getting our first widespread rain that we've had in a long time.
Good. So I just want to remind all the participants today to type in any questions in the chat as I wait for some questions to come in, and I have a couple of myself that I'd like to ask the group. I'd like to introduce Emma Maxim. Emma is a PhD candidate at the University of Wisconsin-Madison, and she's been doing a bit of work about foliar fertilizers, basically prophylactic applications. And this project is led by Rachel Van at NC State and Laura Lindsay at Ohio State University, but a good collaboration across the country and looking at this program. So Emma, the floor is all yours.
Wonderful. Thank you for the introduction, Sean. I would like to start by thanking everybody that made this work possible. This is part of the Science for Success program, and Wisconsin Soybean Marketing Board funded our Wisconsin sites. Other state checkoff boards funded sites at other locations. And thank you to our collaborators, many of which are here today. In 2019 and 2020, we tested 6 commercially available foliar fertilizer products, and they were all sprayed prophylactically, which means they were sprayed before there were any visual symptoms of nutrient deficiency. We had 46 sites in 16 states. In 2019, we had 20 sites. Those are the black circles on this map. And in 2020, we had 26 sites shown in red on this map. They ranged all the way from the Dakotas down into Florida, and about half our sites had silt loam soils, but we had some sites with sandy soils and some with heavy clays. Site average yields ranged from around 30 bushels per acre to around 85 bushels per acre. So all in all, this study really demonstrated the wide range of soybean growing conditions across the United States. There were 7 treatments in this trial, 6 products and an untreated control, and all treatments were replicated around 6 times per site. All products were applied at rates within the manufacturer's guidelines. And I'm sharing this table with you so you can see the wide range of products and the nutrients and rates that they contained. Each product had a different mix of nutrients, and while we can't test all commercially available products, this range of products represents the range of rates, nutrients, combinations, and all the wide range of products currently marketed for soybean production. With that, I'd like to get into some quick results. This is a box plot of yield by treatment across all our sites, and our untreated control is on the left. The black line within each box represents the median yield for each treatment, and all the boxes line up, which indicates that yield did not vary much by treatment. And all the boxes are around the same size, which shows that the range of yield was comparable across all treatments. We did use an ANOVA to test whether there were differences in yield based on treatment, site, or the interaction of treatment and site, and there were no significant differences in yield among treatments. There was also no interaction between site and treatment, which shows that across all 46 sites, there was roughly the same lack of effect of foliar fertilizer on soybean yield. Other noteworthy results, there was no difference in grain, protein, and oil concentration among the treatments. And for the most part, treatments did not have much effect on nutrient concentration. The exceptions to that were manganese, copper, and boron. Tissue concentration of those 3 nutrients increased when a product that contained those nutrients was applied, which probably makes sense, but if it doesn't affect yield, I'm not going to spend much time on it today. I have 2 take-home messages for you. First off, foliar fertilizers do not increase yield in US soybean when there are no visual symptoms of nutrient deficiency. And secondly, since foliar fertilizers do not increase yield, they do not increase profit, even at higher bean prices. I think Dylan Lively is on this call. He was a student at North Carolina and did some surveying of how expensive these foliar fertilizer products are across the East Coast. And even when you're at $15 a bushel for beans, about half the treatments statistically decreased profit. And at lower bean prices, even more of our treatments were associated with a decrease in profit. Since there was no increase in yield associated with these treatments, at no bean price are you ever going to see an increase in your profitability. So again, foliar fertilizers are not increasing yield when there aren't visual symptoms of nutrient deficiency, and they are likely to lower your profit even at higher bean prices. If you're interested in learning more about this trial, you can email me, you can tweet me, you can read the annual report. I'll drop the link in the chat box in a little bit. And we're optimistic that it will be published later this year. I have submitted a full report on this project to Agronomy Journal. And with that, one more thank you to everybody that made this possible. And I'd like to open it up to questions.
Thank you, Emma. Are there any questions from the audience about this this presentation on micronutrients?
Emma, this is David. Although averaged across all the treatments, you showed there was no yield increase. Were there any specific locations that may have seen one or more of the treatments increase yield?
We had one site in Fond du Lac, Wisconsin in 2019 that did have some differences between treatments, but it was also a site with really high variation in yield. And the treatment that had higher yield than our untreated control was supplying mostly potassium, and the other potassium containing treatments did not increase yield. So we're pretty sure that that was a random error effect. We did not see that type of thing at other sites. So 45 out of 46 sites, we were not seeing even really trends worth talking about.
Thank you, Emma. There's a question from Dominic Rissig. Was any tissue testing done? Did they do anything in the plant or nothing at all?
We did do tissue testing. I can pull up that slide one more time. And for the most part, they did not do much. There were 3 nutrients that when they were applied foliarly, we did see a change in tissue nutrient concentration. But for the other nutrients tested here, NPK, calcium, magnesium, and iron, we were not seeing any changes in the tissue concentration. And there is more information on that in the upcoming publication.
So Dominic, to clarify, so tissue testing was, we pulled, or Emma pulled tissue, or the collaborators pulled tissues prior to the application. Then I believe it was 2 weeks after. Emma, you can correct me if I'm wrong, then we pulled another set of tissue samples. So we did it before application and after.
And we were looking at how the change in concentration between those 2 time points change between treatments. We've got another question in the chat. Some reps claim that the benefit from foliar fertilizers is the fact that we are tricking the plant to believe it is happier than it really is, hence increasing yield potential. Is there any truth in this realistically? I don't think so. I think that's anytime I hear we're trying to make plants happy, I'm a little suspect anyway. But also we're not seeing any difference in yields among these treatments.
Sorry, I need to jump in, but I'll open this up to the rest of the panelists about it. I know tissue, the application of prophylactic micronutrients is a common thing across many states, and just want to see outside of this project if anyone else has had any success stories or is it similar to what Emma's found. So any panelists, you're open to speak.
You know, it seems like, this is David Halshauser, it seems like that all of us do these trials every year with someone or another. Occasionally you'll see a response, but 1 out of 20 times, it may be just statistically anomalies that we see. I can recall many years ago, we saw an increase in yield at one site, significant increase in yield, but that site hadn't been fertilized for potassium. It was low in potassium, and the product we used had a little potassium. So the tissue sample showed right when we made that application, it went down in potassium. So I agree with Emma that if tissue samples or visual symptoms are not there, I don't think we're going to see a consistent response in any of these.
I'll agree with that too. There's a lot of work that Mike Staten has done with on-farm trials here in Michigan. I believe more than 100 total trials over the last 10 years or so. And I think they were less than 5%, if I remember, where he did see some response. And that was even not enough to have an economic benefit. So again, I think unless you have a nutrient deficiency present, even then, I think it might be a challenge. But yeah, overall, very few data that we have shows a benefit.
Thank you, Manny. There was a question from Ryan. Would you expect this to be true for growers with a yield goal greater than 85 bushels per acre? So Emma, you could probably speak to that a little bit, given the yield ranges you saw in your trial.
Yeah, our highest yielding site did yield around 88 bushels per acre. And I would expect this to be true for higher yielding fields as well. Just because the amount of nutrients being applied this way is so small. So if you're thinking about your crop removal being higher on your higher yielding fields, these are not even supplying a drop in the bucket for the amount of nutrients you need for those high yielding fields. And we're not seeing other benefits to them, such as higher protein or higher oil concentration in the grain, and we're not seeing much change in leaf tissue. So I'm not expecting to see a benefit for these products on higher yielding fields or as average yields continue to increase.
Thank you, Emma. If anyone else has any further questions about this work, feel free to drop them in chat. And Emma, if you can hold on, stick around till 9 o'clock. If something else comes on, that would be great. Back to something I think Manny had spoken about earlier was a double crop. And I know that personally in Wisconsin, our wheat is starting to come off this week, and we're relatively don't double crop a lot of our acres because our average wheat timing is July 19th. So with this week coming off, I'm recommending that farmers should just give it a shot if you can get some relatively inexpensive seed. I'm expecting here in southern Wisconsin, even with this planting date of around July 9th, we could get anywhere from 20 to 30 bushels per acre if we don't get an early frost. So I know double crop beans is something that many of the participants on here work with. So I'm going to open up the floor. Let's start with Jeremy. We'll kind of move across the country and just talk about what are your recommendations for double cropping.
So here in the Arkansas and particularly the Mid-South, our wheat acreage has really declined over the last 10 to 15 years. 15, 20 years ago, we had over 1 million acres of wheat. And this year, I think we're struggling to get, 150,000. So, my double crop recommendations are pretty much the same as my late planted recommendations. Narrow upper row spacing as much as we can. I prefer drills over wide rows. Increase the seeding rate 10 to 15% over your normal production. We still in the Mid-South recommend seed treatments, fungicide and insecticide, because we do have some complexes of insects and diseases that still show up late in the season, especially Rhizoctonia solani, and then some of the wireworms and grubs and other things that are really moving along late in the season. So other than that, just scout them once they come up and keep our weeds under control, and then scout them late in the season for insects and diseases, because they're going to be some of the last soybeans that are going to be in the field. So they're going to kind of be biomagnets for some of these insects and diseases. So we really want to make sure we scout those fields and put out the needed insecticide and fungicide when needed. And of course, irrigation. We don't recommend, we recommend irrigated soybeans in double crop situation 100% of the time. So.
Thank you, Jeremy. Let's move over to Illinois. Emerson, what are your thoughts and recommendations?
Well, when you grow wheat in Illinois, for the most part, you double crop it, or you plan to. And when people plan to, these days they do. About 80% of our crop is in the southern half of the state, concentrated in the southwest over towards St. Louis. And that would all probably be double cropped as of today, unless there's a few fields that are too wet. So our wheat harvest starts early there, it ends early. It's usually done before the end of June. And it's become a routine, and it's a high profit cropping system for that part of the state. It has moved up some into the central part and even to the northern part sometimes. And I think I'd echo what Manny said and what you said, Sean. If you've got the wheat off by the middle of July, you can give it a shot. A few years ago, we had a lot of planting in southern Illinois, double crop planting that was well into July, even to late July. And we still got a crop if we planted up through the end of July that year. That's not always going to happen, but I think the general improvement in varieties have meant that they have a lot better ability to do something if planted in when the season's half over, compared to what would have been the case 20 years ago. So we don't talk about doing anything special. Most of ours are in 15-inch rows, and that's fine. We don't really talk about raising the seeding rate because we don't know that there's any need to. We like the crop to make a reasonable amount of growth. If it gets a good enough rainfall, it will do that. And it shifts the critical period for the bean crop later, of course. And instead of month of August being the time when we make our yield, that's shifted back by 2 to 3 weeks. But a lot of times in southwestern Illinois, we get wet weather in the spring and planting is delayed anyway. So if we get good rainfall to replenish that moisture that wheat crop took out, we're generally going to be in pretty good shape. And we don't generally suggest spending money, finding new ways to spend more money on the double crop than we do on the main crop, which some people have the idea, I guess, if you spend more money on it, it will yield more. And it's highly dependent on the number of days with sunshine and adequate soil moisture as to what kind of yields we're going to get. But certainly, there many farmers have seen yields of 40 to 50, even higher in good years with double crop soybeans. And we don't see any reason this year would be any different.
Thank you, Emerson. Let's go to the East Coast, get a different perspective. So David, you're up.
Yeah, thanks, Sean. Our double crop bean acres are down. They've been down for the last few years. We're only about 20% of our acres now, double crop beans. We have been, on average, we're 40 to 50. We have been as high as 2/3. Historically, for our grain soybean growing areas, that is our bread and butter. That wheat soybean double crop was. Wheat yields have been down. Wheat's not been doing as well. I think our climate has a lot to do with that. We're getting rain on the wheat when we're needing to harvest, and as this year we just didn't get enough rain for it. So that's where it's going. I think the biggest mistake growers make with double crop is they treat it either like they're what I call full season beans, or they treat it less than the full season beans. It's a different crop altogether. You need to pay attention to it and treat it well. I have 3 basic principles for growing double crop beans, and this pertains largely to the mid-Atlantic southeastern states, low water holding capacity soils. And that is position that crop for the longest growing season possible, and then grow as many leaves as possible, and then protect that valuable leaf area. If you follow those 3 principles, we can have a good double crop soybean. Now, that first one is probably the most important. Position that for longest season. We just completed a 5-state 3-year project that showed planting date was 75% of the yield. So, and earlier your plant, we gain on average about a half a bushel a day with every delay in planting. Most of our farmers will be planting the same day they harvest wheat. We're now pushing high moisture wheat harvest, continuous flow dryers. I know some folks are harvesting the wheat at 20%. We've even got a few mills that will take it without any dockage. But you got to get it in a dryer quick. And by that way, they've been able to plant, a week, 10 days earlier. So that's the key thing. Growing leaf area, yeah, higher seeding rates, narrow rows. And I always suggest grow the longest maturing variety as possible that'll mature before a frost. Because again, we're just growing leaves. In our low water holding capacity soil, that's our big problem. We can't grow enough leaves out there. And I'll echo what Jeremy says, insects and disease as well, really. If the conditions are right for disease, I think we probably see more disease in double crop on average if the conditions are right. If we start getting rains during those reproductive stages, which we sometimes do because that stage is pushed so late. It's more than you want to hear, I'm sure, but that's my quick, elevator speech about that.
So David, many of us are an extension here, so we always give more information than our audience really wants to hear. So that's pretty common. But David, there's a question for you in here. What is the last date you would recommend planting double crop beans in the mid-Atlantic? Hey, David, you're muted.
We have planted soybean in August after corn. I've seen people do that. And again, they say, hey, I can get beans for less than, 15 bucks an acre because it's just what's out there. One application of Roundup, what I have to lose. I don't recommend that. July 15th, you can probably still make a crop. It's not going to be necessarily profitable, but if you can get those, some cheap beans, maybe one application of a herbicide and just do what you can possibly. And it's going to take a late frost, but we can still make it with we can make it to the end of the growing season with July 15th on average.
Thank you, David. There's a question for the panelists. As we continue discussing planting earlier to derive yield, how does this impact oil and protein composition? So I will just throw that out to the panelists, and whoever wants to go first, go first. Or I'll pick somebody.
Historically, our double crop beans are our highest protein. And I think that's largely could be due to the yield less, could just be that yield factor. That's not always the case, but we also, they don't experience that wet, hot, humid time that we see when beans are maturing in late September, early October. So it's a cooler time. Yeah, I'd say historically our best bean quality and protein levels are with our double crop beans.
Yeah, I'll address that topic as well. So we had an opportunity to do some research on this a few years ago with this decades project that we had, where we had germplasm from basically the 1920s all the way to, at that point, it was like 2014. And what we've seen over time is that our protein level has dropped. And then as we plant earlier, we see our protein level dropping as well. So that's a kind of a function of, part of it is the temperature during the temperature and the weather during the grain fill period has an influence on protein and oil. And but I see Emerson went off mute, so I'll let Emerson take the floor if he has any follow-up.
I just make a quick comment that protein and oil tend to be sort of inversely correlated. So low protein or high protein usually means lower oil. And it's very complicated. Having to do with weather during the grain fill probably is more than anything else.
Thank you, Emerson. I've been getting a bunch of calls lately about nodulation concerns, given the weather we've had. And I just want to open that up to panelists here of what you've seen across the country in terms of nodulation and what that impact of nodulation has, resulting in yield. So Emerson, since you're off mute, I'll let you have the floor first.
Well, I'm retired and too lazy to dig plants up. So when they turn dark green, I figure they're nodulated fine, and they always are. This year it took quite a while for them to turn dark green, but most of the fields did or will once they get a little bit more oxygen. So we're, the concerns that we always have when the crop is getting started usually disappear. I've suggested in the past, because we've seen some big yield increases from planting time applications of nitrogen, that you could do a little test in every field, hand spread a little bit of urea and see if those green up faster and stay ahead. We would expect to see that in the lighter textured soils, not in silt loams and silty clay loams.
So Jeremy, given the challenges you've had down in Arkansas, what are your experiences with nodulation and using an inoculant every year? Does that actually do anything down there in Arkansas?
Yeah, especially where we had the flooding issues, we've had some issues with good nodulation. Actually, Trent Irby was texting me some pictures yesterday and he's having some issues as well. And talking to him, and from, here in Arkansas, most of the time where we see problems is in fields that have not been in beans, the last 3 or 4 years, had recent land leveling. And so they probably, disrupted the native population. But, we've looked at inoculants for several years, and we did see some increases in yield with the use of inoculants late in the season. So we were typically, once we get into that, our typical double crop timing, into June, we recommend, inoculants no matter what. If you've had beans the last several years, we're still recommending inoculant. We're seeing a significant increase in yield, enough to pay for the inoculant plus some. But overall, the weird year we've had, I've seen a lot of just nutritional issues, beans that are yellow, but they've had, a good pre-plant fertility mix. The root systems have been really stunted, because it's either been too dry or too wet. And so overall, it's just been a really odd year for nutritional deficiencies and trying to keep on tabs with all of that. But inoculants, I think they work. I look at them as kind of cheap insurance. I'd rather a producer look at inoculants versus some of these foliar feeds that they're spending a little bit more money on late in the season. I think you'll get potentially get a bigger bang for your buck with inoculants than you would with some of the foliar products. So.
Thank you, Jeremy. I see Damon Smith was able to join us, so I'd like to introduce Damon Smith. He's the Extension Field Crops Plant Pathologist at the University of Wisconsin-Madison, and he's done a lot of work on white mold, and I know that maybe isn't a concern for some of our southern growers, but it is, definitely for some of the northern growers and crop consultants on here. So we have Damon talk a little bit about some of the apps he's developed, Spore Buster and Sporecaster. So Damon, the floor is yours.
All right, thanks, Sean. Hopefully I can keep my screen on. Let me know, Sean, if I start glitching in and out or anything, and I can turn my screen off. I'm in Arlington with a limited connection this morning. I am going to share my screen here just so I can talk a little about what we've got going on with the app. They can see that okay. And we'll actually do some stuff in real time. So Sean just wanted me to hit a little bit on both Sporecaster and Spore Buster. We have several other apps that we've developed through the Nutrient Pest Management program here. I won't talk about those today, but a lot of cool things that have come along. The Nutrient Pest Management program here at UW has been doing apps basically since apps started. So we have quite a few different things, and the latest ones here are these Sporecaster and Spore Buster apps, and these are meant to be complementary with each other. So I'll first talk about Sporecaster here, which is the one we've spent most of our time on. We have 3 research publications that back this work, so it is truly research-based work here. So we did a bunch of model development with Marty Chilvers at Michigan State and Darren Mueller and myself, and basically, the models that back Sporecaster are probabilistic models. So these are different than some of the traditional plant pathology models that have been developed, which rely on, esoteric terms like disease days and all this sort of thing. We just went right to probabilities. So these are like, rain forecasts. So we're simply fitting logistic regression curves here using different weather parameters and some other biological things that back these models. Essentially, we try to, we tried to take the 3 papers and cook this down so a farmer can, get the forecast in the matter of a couple of seconds. So the first thing they need to do here is just set a field up. I'm just going to go ahead and do a test field where I'm sitting here at Arlington today. We do ask about row spacing, what they've planted. Now in the north central here, we're primarily on 15-inch and 30-inch row spacings. For the non-irrigated models, we do run 2 separate models, one for irrigated and one for non-irrigated. For the non-irrigated, it doesn't really matter because we account for row spacing basically in that model. In the irrigated model, it does become a little more important what the row spacing is, because we do adjust the model on the fly. So I'm just going to actually set just a regular 30-inch non-irrigated today. It did hit my GPS coordinates, so it's automatically aligned to where I'm sitting, but you could also go in here and drag things around. And, I could even, we got some of our research fields sit right here. I can even drop a point right there and set that in the office. So it can be done either in the field or in the office. We hit done, the field is now set. And I can run the model. So we do ask a couple of questions related to the biology and phenology of the crop. So our flowers present, we know that for white mold, we have to have flowers there. So it's R1 to R3. So we just ask that simple question. That's a toggle switch that turns the app on and off. And then some of the work we did with Marty and a postdoc he had at Michigan State, we worked on row closure, and between row closure is really important. And there's actually a really fine or stark threshold that has to be met on between row closure. And we actually give the user an example in terms of a picture of what is under threshold and over threshold. It turns out it has to be 40% between row closure before we start getting apothecial development. So the whole model is basically built around trying to predict the development of this little mushroom. So we're just trying to purely model the fungal biology as it relates to the soybean crop and the soybean canopy. So they can make a decision on whether they're between row spacing. This is especially important, obviously, in our 30-inch rows and our 15-inch rows. We don't even ask this question because you're just about always, met that threshold when the crop is flowering. So we'll just cheat here. We'll say, row closure is met. I'm going to actually allow auto field refresh, and I'll show you how that works in a second. And then I can run the model here. So what it did is it went up into the cloud. It pulled down weather data for that GPS coordinate, and it ran it through the appropriate logistic regression model that was programmed in the background and gave us our low, medium, and high. We can also do some other things with the locations. You'll see here, I've got multiple locations set up, and I have all these set on what I like to do is an auto refresh. And this is especially handy for us as researchers when we're trying to get an understanding of statewide, risk and how that risk gradation is across the state. And when I click that auto refresh, I can actually come in the morning, I can just click down and that'll auto refresh all my locations. So I don't have to, once I have everything set in that particular field, I can just auto refresh all my locations on the fly. And then I can go to the map function here, and you can see I've got a lot of points, especially for Wisconsin here, and I can kind of see on the fly where the risk gradations are across the state. Obviously, this could change a little bit depending on the models you have programmed. I've intentionally, with this particular map, programmed everything to be a non-irrigated situation. But you could work in irrigated models and all sorts of things in here and just kind of run those on the fly. So you can see we're in the sort of moderate areas here for much of the state. We have some areas up in the northeast, which are high, and kind of some areas in the central. And this does align pretty well with where we've had our rain events. We have a really significant drought down here in the southeast right now, and so I'm not surprised to see that low. So the biology here in the models does seem to align pretty well with what's going on with the particular weather conditions right now in the state. So this can be run in Canada and all of the US. You can get these predictions basically on the fly, and a farmer can do it, in the field as long as they have an internet connection. Now, one thing we've done is we said, all right, well, we have the risk prediction thing, but how do you make the decision on what to spray? And that's why we developed Spore Busters. So we did a lot of yield loss work along, this again with some works, separate work with Marty and Darren Mueller at Iowa State and some other folks who contributed to this work. Again, our research backed, we published on this. We know our yield loss models and when it comes to white mold and soybean are actually nonlinear. So One thing that's really important is actually the disease pressure that we have in a field situation. So we ask a farmer when we go into the Spore Buster app and they're trying to understand what programs they should be using for white mold control. We do ask them what the historical pressure is. And again, we give them a sort of a visual. Are you in a sort of a low pressure, moderate pressure, or high pressure situation? Because when we look at the yield loss curves in a low pressure situation, you know, that yield loss curve is negative, but it's not very steep. And then we get to moderate and it starts to break over. Again, we're dealing with a sort of a logistic trend. And then when we get to high, it's an extremely steep slope in terms of yield loss here. And so it does, the economics and return on investment do depend on the historical pressure of white mold in that particular field. So we ask them those questions, but they can run all sorts of different scenarios here to try to figure out what the return on investment might be for some of the programs that are labeled for white mold. So, you know, we'll just set you know, an expected price of sale for the soybeans. We've got an expected yield here. I'll just go with 60 bushels. I'll go ahead and set this for high. And you can see that once I answered that information based on our farms, this auto-tabulated in terms of average net gain and some things that were fit into our economic models. We worked with Paul Mitchell here and Ag Econ to develop these different models. And you can even go in and you can adjust the pricing of the products. For instance, Endura is one of our best products here on white mold. We can actually change that price there to be more realistic with what might be for the local condition, and then the list will actually auto adjust and refit those average net gains and et cetera. And just to show you what basically, you know, happens when I move the disease pressure thing around, you can see when I go to low disease pressure, you get a lot of the cheaper products sort of drifting to the top, and some of the more expensive programs now become a negative net gain. So folks can play with this, and this is in line with what we've seen with some of our work where, you know, in a low disease pressure situation, there's a lot of things that work, and it really comes down to just, you know, going with the cheap. When it becomes a more high pressure, historically high pressure situation, then they want to, you know, probably focus on some of the more expensive programs. In fact, get a pretty good return on investment. So we found this is pretty nice for farmers. They can play around with their local price scenarios and kind of run different return on investment scenarios for their farm and that sort of thing. So both Sporecaster and Spore Buster are meant to be complementary to each other, and hopefully folks are downloading them together. We do have both the apps available on the iPhone and Android platform, so we don't discriminate in terms of, you know, the smartphone platform there. So with that, I'll just stop screen sharing. Hopefully, Sean, that's what you were looking for there. I can take any questions if anybody has any on the apps or the models or what we've been doing with those tools.
Thank you, Damon. That was exactly what I was looking for. So do we have any questions for Dr. Damon Smith on the use of these apps? So just as a follow-up, these are all free to download, and these were sponsored by the Wisconsin Soybean Marketing Board. So your checkoff dollars at work. So if there are any questions for Damon, we've got about 2 more minutes while we're going to be on air. Feel free to type something in the chat, or anyone else has any questions for any of the panelists, feel free to type those in the chat over the next 2 minutes. So while we're waiting for questions, I just kind of want to give a little personal update. One of the interesting things is I gave my first in-person talk in like a year and a half last Monday, and I was awful. So I guess I was a little bit out of practice, but it was kind of an interesting thing to be inside without masks and in front of a group of people. But I'm glad that things are opening up and we have opportunities to go out and, you know, I think everyone had a weed science field day yesterday, because I was following on Twitter. We had one here in Wisconsin. I know they had one in Iowa, so and in Missouri. So I think it's time that we're all getting back together, and it's fantastic. So
Damon, in these dry areas, is one rainfall enough to trigger sporulation, or does it take more continued wet than that?
Yeah, great question, Emerson. It really takes about 30 days of accumulated weather patterns to trigger the formation of the mushroom. And there's been a lot of work in field as well as in growth chambers to show that. And so what we've done there is we actually use 30-day moving averages to accumulate that. So you'll notice things move rather slow because you have to accumulate that 30-day trend. But it's interesting this year, things were running pretty low. And then about 2 weeks ago, we started getting some rain, and now I'm seeing it slowly start to creep up. So what I'm telling folks is I think the epidemic is going to be a later onset epidemic this year, pushed later into R3. Some early planted soybeans that are already flowering and headed towards first pod set here are probably going to escape. So it's going to be some of the later planted stuff that we need to keep an eye on. So yeah, great question. It's not just one rain, certainly those conditions contribute, but you really have to accumulate weather over that previous 30 days to start to build that risk.
And after R3, then you don't even run it anymore.
Right, after about first pod set, and that's in line with some of the yield loss work that we had done for the Spore Buster build. We see very little economic return. The risk, the infections don't really occur after that, or at least economically important infections at that point. So you can pretty much stop running it, and there's little return on investment after about the R3 to R4 growth stage in terms of applying a fungicide for white mold.
I know we're 1 minute over, but there's one more question there I'm going to address to Damon. Are you planning to develop a similar app for other diseases?
Yeah, we actually have plans. The next one we're looking for is we'd like to develop a frog eye leaf spot app. We also are interested, some colleagues at South Dakota State are interested also in diaporthy diseases, so the stem canker groups and pod and stem blight groups. And so we actually do have several grant proposals in at this point to tackle those. We have the framework in place now with Spore Castor. In fact, we've started moving. We developed a tar spot and released a tar spot on corn model this year that's based on that same framework. So it is a pretty nimble framework. That's the nice thing about these probabilistic models. It's just a matter of refitting and retraining the models based on the appropriate weather parameters and biology parameters that go into that. So we're hopeful that if we can get funded, the data sets are out there, we can start building and validating and pushing some more disease prediction tools out there.
I'll just take a quick stab at that question that was asked about if leaves show fertility need, how long does a spray fertilizer take to correct it? The answer is probably 2 days. I mean, it gets taken up quickly if good sunshine, and if it really is due to a lack of that specific nutrient, it will correct fairly quickly. A lot of times it's due to root problems and other things, so that may not correct.
Thank you, Emerson, for taking that question. And thank you, Damon and Emma, for joining us today as guest speakers. So to be respectful of everyone's time, I'd just like to thank everyone and our panelists today and those who have attended, and have a great Friday, and we'll see you all in a month. Thank you. Have a good day.